Okay, hi everyone. So today I'm going to show you how to find the equations of a line in space. Okay, to do so I'm going to start with something that we know, which is a line in R2. And then I'm going to transpose that same logic into R3 and use it to show you how to find the equation of a line in R3. Okay, so just remember one thing. In high school, when we were asked to find the equation of a line, you were always given two things: a point and a slope. A point is a fixed place where the line goes through, and a slope is really how slanted the line is, in fact, what direction the line takes. So we'll do the same thing in R3. So let's go over the R2 first. Okay, so what's happening in R2? Let's say I have a line that passes through point PO. So XO, YO, and has a slope A. Okay, and I'm asked to find the equation of this line. So what do I do? Well, there's a few methods to find, but the one that I'm interested in today is, let's say I'm taking a random point XY on that line. So since the point XP, the point P is on the line, then the slope between PO and P has to be A. Okay, no choice. Because if the slope between PO and P was not A, that would mean that point P is not on the line. Okay, so we must have y minus yo over x minus xo equal to the slope A, right? Delta y over delta x equals A. We're all familiar with this. Let's isolate y now. So y minus yo is equal to A times x minus xo. And so that means that y is A times x minus xo plus yo. Okay, that's how I find the equation of a line in R2. Let's do an example, okay, just to be clear. So I'm going to separate this here, and let's do this example right here. So we're asked to find the equation of the line passing through point P37 that is parallel to the line y equals 2x plus 7. Okay, so solution. Okay, so we are given what? We are given a point. My point is P37, and we are given the slope. So what is my slope? Well, since my line is parallel to 2x plus 7, so basically we need to have the same slope, so the slope is 2. Okay, so again, just like we did here, y, x, my line, I have my point here, P37, my slope, now I know that my slope is 2, and I'm taking a random point, Pxy on the line. So, same logic, we must have delta y over delta x equals to 2. So y minus 7 over x minus 3 equals to 2. And if you isolate y, so we get y minus 7 is 2 times x minus 3. And so we have y equals 2x minus 6 plus 7, so 2x plus 1. Okay, in other words, if I want point Pxy to be on the line, x and y need to be linked by this relation. The y has to be equal to 2 times the x plus 1. That's the only way. Okay, and you could check. 2 times 3 plus 1 is 7 indeed. Okay, so now let's do it in R3. Okay, so same idea. Remember, we need a point and a direction. So in R3, what do I have here? Let me draw my Cartesian frame here. X, Y, Z, and here is a line in space. And so again, I am given a point, PO, so XO, YO, ZO, and now I'm not giving a slope, I'm giving a direction, so a direction vector, right, in the direction of the line, so D, A, B, C. Okay, so now let me take a random point on the line, so P, X, Y, Z. So what must happen for this line, so for this point to be on the line? Okay, well, I need the vector, the vector joining PO to P to be parallel to D, to be in the same direction as D. Okay, so I'm going to write this down, but this is my vector here, POP, has to be parallel to D. So we must have vector P, O, P parallel to vector D. Okay, and this is equivalent to what? This is equivalent to saying that POP is equal to a multiple of D. Okay, now what's POP? POP, how do you find the component of this vector? Well, you just minus the coordinates of the endpoints. Okay, so the end minus the original. Okay, so X minus XO, Y minus YO, and Z minus ZO has to equal to T times vector D, which is ABC. Okay, and now if I isolate X, Y, and Z, so X minus XO is TA, Y minus O is TB, and Z minus ZO is CT. So let's write this down. So X has to be XO plus AT, Y has to be YO plus BT, and Z has to be ZO plus CT, and these are the parametric equations of a line in R3. Okay, it's called parametric because T is my parameter here. Everything depends on T. T generates points. Okay, depending on what T is, X, Y, and Z take on different values, so it's a different point on the line. Okay, don't forget, XO, YO, ZO is given, ABC is given. Okay, let's do an example just to visualize this. Okay, so here we have find the equation of the line passing through point P296 and Q48 negative 1. Okay, so let's go, solution. So again, I have a point. So my point, I will take either P or Q. I'll take P. So 296. And the direction, so I don't have a direction, but I'm just going to take vector PQ, okay, as a direction. So direction, I will take vector PQ. So 4 minus 2 is 2, 8 minus 9 is negative 1, and negative 1 minus 6 is negative 7. So this is the direction. So I have the point, I have the direction. Well, It's very simple now. If I have the point XO, YO, ZO, here he is, 296. The direction ABC is 2, negative 1, 7. Here it is. So it's very simple. So the parametric equations are so x equals y equals z equals. So x is xo plus at, so 2 plus 2t. Y is yo plus bt, so 9 minus 1t. And z is equal to zo plus ct, which is 6 minus 7t. And these are the equations of my line passing through point P and Q. Okay, so what does this really mean? Is that we have 3 dimensions here, my 3 axes here, and I have my line. And on my line, I know that I have point P296 and my point Q 4, 8, negative 1. And depending on what I choose to set as T, I will get a different point X, Y, Z. Okay, so for example, let's say T is 0. Well, if you plug in 0 in the T, you will get 0.296, which is in fact P. If we put T equals to 1, we'll get 4, 8, negative 1, which is in fact point Q. If I put T equals, let's say, negative 1, I will get 0, 10, 13, which is point, let's call this point R. Okay, so it's a point, I have no idea where it is, it's not important, but it's definitely on the line. This is my point R, 0, 10, 13. And I could keep going forever, generating different points just by plugging values to parameter T. You will see soon in the course that we'll parameterize surfaces in the same idea, except there will be 2 parameters, of course, because a surface has 2 dimensions. Okay? We'll get to this when we talk about the dimension of spaces.